Here we're being asked to calculate the distance between two given points, and at the end of the day it is just this formula that you have to use. But I really want you guys to know where this formula is coming from, because it's kind of a hot mess in terms of symbols and subscripts and square roots, and really it all comes back to this Pythagorean theorem. And the reason why I want you guys to understand that is because this formula, no one really cares about the distance between 2 points. This is always part of a bigger problem. And so you don't want to have to be like fumbling with this or getting this stuff wrong. So check this out. I know that everyone has learned that if you have a right triangle, that the relationship is that a squared plus b squared equals c squared. And if you know that that's true, then it's not too much of a stretch to realize that c by itself, if I square root both sides, equals the square root of a squared plus b squared. Now, we're asked to find the distance between these 2 points, and the trick here is to kind of make these 2 points into a right triangle like so, and what we're trying to find is this distance, which, if you look at it this way, is the hypotenuse of a right triangle. So what we need to figure out is a way to calculate this value here and this value here. And it just so happens that this distance is going to be whatever this guy's x value is and whatever this guy's x value is. If you take that difference, that's how far apart, that's how the length of this leg. And this distance, this up and down distance, is going to be this guy's y value take away this guy's y value. And honestly, it doesn't, I'm kind of like pointing to specific ones, this one minus this one or this one minus this one. It doesn't really matter what order you do anything in for this problem. I could call this guy x1 and y1 and this guy x2 and y2, or I could do it the other way around. In fact, because things are squared, I could totally screw all that up and none of it's going to matter. At the end of the day, what I have to do is take the difference of those x values and square it, and the difference of those x values will give me the length, like this leg, and then you take the difference of these y values to find this leg and square it, take the sum and square root it, as if I was doing Pythagorean theorem. So that maybe makes things sound a little bit more complicated, but when you think about trying to memorize this formula, I know when I was learning it as a kid, I couldn't remember like where the minuses went, where the pluses went. So at the very least, once I knew how to tie it to Pythagorean theorem, I knew that the symbol between them was added, because that's what we do with Pythagorean theorem, and the symbol inside of these things was subtraction, because I was trying to find a length. So having said all of that, here's all you really have to do. The distance is going to equal the square root of, oh, now I need to erase some of the mess I made up here. The distance between these two things, so that's going to be 2 take away a negative 1 squared, plus this guy take away this guy. And again, that order actually is pretty irrelevant. If you did negative 1 minus 2 or 5 minus negative 1, it's not going to change the final answer at all. This is going to become a 3 squared, plus that's going to become a 6 squared. That's the square root of 9 plus 36. That equals the square root of 45, which is equivalent to the square root of 9 times 5, or 3 root 5 as our final answer. That's it. This formula comes up so many times coming forward in your math classes, and if you can make peace with it and tie it to Pythagorean theorem, it's not going to be such a terrible thing every time you come across it. Good luck with these.